Mankind's story of the expansion of the universe begins with Festo Slipher, an astronomer who worked at Lowell University almost 100 years ago. Slipher spent his time measuring the rotational speed of nebulae using spectrography. But while he was recording these nebulae rotational velocities, he came across some anomalies. According to his observations, these nebulae had to be traveling thousands of kilometers per second. Several years later, Edwin Hubble built on the works of Slipher and made a new interpretation that what Slipher was seeing was not nebulae, but in fact other galaxies. Hubble got another insight from his observations that the further away galaxies were moving away from us quicker than the closer ones. This is the basis for Hubble's law, which states 1. Objects 10 megaparsecs or more away from Earth can have their Doppler shifts interpreted as relative velocity away from Earth, and 2. The relative velocity is proportional to the distance between Earth and the object being observed. Another scientist by the name of George Lemaitz used Hubble's discoveries to support his idea that the universe was expanding. Once we understood that space is expanding, it led to more questions. When did it start? When will it stop? And what causes it? Well, the answer to the first question was by George Lemaitz, who proposed that if you ran the expansion in reverse, then the whole universe goes into a state that he called the primeval atom. This is what we now know as the Big Bang Theory. But the Big Bang doesn't explain why space started expanding. For there to be a bang, there has to be something to set it off. One possible explanation for the initial expansion of the universe was given by Alan Guth in 1979. He proposed that a Higgs field caught on an energy plateau would fill the universe with a negative pressure that would drive expansion. Physicist Andre Linde further contributed to this idea by adjusting the Higgs field's energy potential to eliminate the possibility of the Higgs field from being caught on its energy plateau, thus preventing permanent rapid expansion of the universe. An alternate explanation for the initial expansion of the universe comes from the cyclic model, but I'll cover the cyclic model a little bit later in the video. Now that we have an idea of what started inflation, now we can delve into the problem of what's going to happen with the current expansion. Despite conventional logic, which would say that the universe expansion should slow down and stop, it isn't slowing down. In fact, it's going even faster. This mysterious force that continues to drive expansion is called dark energy. Dark energy is a hypothetical energy and pressure filling the universe. It acts sort of like a cosmological constant that Einstein proposed, except it isn't constant because it changes over time. Now, if expansion keeps accelerating, then what happens to the rest of the universe? Well, there are several proposed outcomes. The first is the Big Crunch. In this model, the expansion of the universe just stops, and then reverses, bringing the entire universe back into a singularity. The Big Rip is the second model. In this model, the force of expansion continues to accelerate. At a certain point in time, all matter and energy is torn apart and isolated from each other in a seemingly infinite emptiness. And the third model I'll mention is the cyclic model. The cyclic model proposes that the universe will continue to expand until the universe is approximately a perfect vacuum. At this point, string theory comes into play. In this model, our universe is the surface of a membrane, which becomes flatter as it expands. This is when our universe starts to drift towards another membrane. As the membranes approach, they start to wrinkle and fold until they collide with each other. When the two membranes collide, they distribute matter and energy into each other. One of the strengths of this model is that it gets around the always increasing entropy problem, because it allows it to reset when the branes become almost perfect vacuums. Science has come a long way since we discovered the universe is expanding, and a lot is still being worked out and discovered. Who knows what the future will bring?